Hi everyone, in this video we are going to be completing a Unit 6 test review over the Pythagorean Theorem. All right, let's not waste any time, let's get started. So first, let's go ahead and review what the Pythagorean Theorem is. So the Pythagorean Theorem is a squared plus b squared equals c squared. And you might look at that and just say, all I see are 3 different letters being added or subtracted together. Well, that's because a theorem is similar to a formula. So if we think about our formula for finding the area of a square, area is equal to length times width. Or if we think about our formula for finding the volume of a sphere, volume is equal to 4/3 times pi times radius squared. That is very similar to the Pythagorean Theorem, where we have a nice little setup for us that we can use to find missing side lengths of a right triangle. So the Pythagorean Theorem only works with right triangles. So if we look at this diagram here, we see a right triangle, and we know that it's a right triangle because we have that nice little 90-degree, that right angle box. When we have our triangle, every triangle has 3 sides, and those 3 sides are our A, our B, and our C. So our A, our B, and our C. With right triangles, 2 of the sides, so your A and your B, if they are squared, that will always add up to equal the 3rd side, so your hypotenuse squared. It is always important to identify your hypotenuse first. That's why it's in red. That's why it's a different color. So your hypotenuse is always the side of your triangle that is straight across from your right angle. It also is always the longest side of your triangle. The other 2 sides are called your legs. And your legs are the 2 sides of the triangle that make the 90-degree angle. And those are interchangeable. They can either be A or B. All right, let's get started because the best way to learn is through an example. All right, so this example is very similar to questions number 1 and 8 on your Unit 6 test. So 1 and 8. And we are being asked to find the value of x. So here we have a triangle, and I do see that it's a right triangle. That means I can use the Pythagorean theorem to find x, to find that missing side. The very first step is we need to label the sides of our triangles, because it is important that we know which 2 sides are our legs, so our A and B, and which side is our hypotenuse, our C. So I always start with the hypotenuse. The hypotenuse, remember, is the side that is across from your 90-degree angle. So right here we have our 90-degree angle. So straight across from that would be this side. So 13 inches, that side is our C, which means the other 2 sides become our legs, so our A and our B. I just always usually make the first one my A, so 12 inches is A, and then the second one is B. So B is our X. B is what we are trying to find. That's the missing side. So that's step 1. We labeled our triangle. Step 2 is substitute the values into our theorem. If we look at our Pythagorean theorem, we have A squared. Well, we know that side A is 12 inches. So instead of A squared, we can have 12 squared. And then that is plus B squared. Well, that's the one we don't know. So you could either write B squared or you could write X squared. Doesn't really matter. We'll go ahead and do X squared for this one since it's telling you that's the side. and then it is equal to c squared. Well, side C, our hypotenuse, is 13 inches. So 13 squared. All right, now that we've substituted our values, we need to simplify and then solve for x. So when we're simplifying our equation here, we follow the order of operations. So PEMDAS, please excuse my dear Aunt Sally. So if we think through order of operations, P, parentheses, grouping symbols. Do I have any of those? Nope. So next down the list, exponents. Do I have those? You bet I do. I got lots of them. So that is our next step. All right, 12 squared. Well, 12 is probably the max number that you have memorized, because I do encourage you guys to have your perfect squares memorized 1 through 12. Anything above that, you're more than welcome to use a calculator. So 12 squared is 12 times itself 2 times. So 12 times 12, which would be 144. And then next we have x squared. Well, that's what we're trying to find is x, so I can't exactly do that, which means it's going to stay x squared. And that is equal to 13 squared. Oh, another exponents. So 13 squared would be 13 times 13. This one you do have permission to use a calculator for, because it's past 12, so it's not a requirement to memorize it. 13 times 13 is 169. All right, at this point, we've done all the simplifying we can. So now we're in solving mode. We need to solve that equation, which is something we learned last semester. So if we're trying to solve for x, we're trying to get x by itself. Remember, when we do equations, we always complete the inverse, so the opposite operation, which means if we have a positive 144 being added to your x squared, the inverse of addition is subtraction. We're going to subtract 144 from both sides. 144 minus 144 is 0, so we're left with x squared. And then 169 minus 144 is 25. All right, we're so close to being done. But the trick is, we're not done because we have an x squared. And if we look back at the directions, it didn't ask us to find x squared, it asked us to find x. So just like we did a moment ago when we solve equations, we have to do the inverse. What is the inverse? What is the opposite of squaring something? Well, that's square root. So to solve this, we need to take the square root of both sides. So the square root and the square are inverses. They cancel each other out, which means we're simply left with x. And then now we need to take the square root of 25. So this is something similar to your squareds that you should have 1 through 12 memorized. Anything above that you can use a calculator for. But because I want to make sure you guys know how to use the calculator, I will show you on this case. So whether you're using a calculator on your phone, whether you are using the Desmos scientific calculator, you will see that there is a square root button. For me, if I choose to use my phone, I have to turn it sideways to make it a scientific calculator. Then when I do, I hit the square root button, enter in 25, and it gives us our answer of 5. And 5 is our value for x. 5 is our missing side, which means this triangle right here has the side lengths of 5, 12, and 13, and it makes a right triangle. We will go ahead and try one more of these. So this one is very similar. It is also like questions 1 and 8. Okay? But this time, you're going to notice we're going to look for a different side. That's why we're going to do one more. All right, we are being asked to find the value of x. We're being asked to find that missing side, and we are given a right triangle, which means I can use the Pythagorean theorem to find x, to find the length of that missing side. Just like before, our first step is to label our three sides so we can know which two are our legs, our A and our B, and which side is our hypotenuse, our C. Well, our hypotenuse is always the side that is across from, so opposite of our right angle. Here we have our right angle, which means if I look straight across, that would be this side, and that is x. This time, we are being asked to find our hypotenuse. That's the slightly different part. That means our other two sides must be A and B, and they do come together to form a right triangle. So we can make 4 miles A and 3 miles RB. Second step is to substitute all of our values. We look at our formula, we have A squared. Well, A is 4 miles, 4 squared. Plus B squared. B is 3 miles, so 3 squared. And that is equal to C squared. Once again, you can either use C squared, or since it's asking you to find the value of x, you can use x squared. Doesn't really matter. Last time I used x, this time I'll use C squared. All right, second step is to simplify. So follow that order of operations. What's the first thing we need to do? Exponents. Alrighty. 4 squared means 4 times itself 2 times. So 4 times 4 is 16. 3 squared means 3 times 3, which is 9. And then C squared, that's a variable. I don't know, so I'm just going to leave it as C squared. Right, this time I have a little bit more simplifying to do because both of my numbers are on the same side of the equation. I can go ahead and add 16 plus 9, which would be 25. Oh, that's kind of funny. Didn't realize it was going to work out to be almost the same. And that is equal to C squared. All right, we're close. Now we need to finish by solving our equation because we know 25 equals C squared, but I don't want to know C squared. I want to know C. The inverse of a square is a square root. So we will take the square root of both sides. The square root of 25 is 5 because 5 times 5 is 25. And the square root of C squared is just plain old C. So that means the length of our hypotenuse, our value for x is 5. And in this case, it would be 5 miles. All right, sweet. Our next one is very similar to questions 2 and 4 on your test. So this is actually going to be the opposite of what we just did. So in the first two problems, we used the Pythagorean theorem to find a missing side. In this one, we're going to do something a little different. All right. So does this set of side lengths form a right triangle? So now we're being given 3 sides, and we're like, hey, use the Pythagorean theorem, see if the Pythagorean theorem works, because if it works, sweet, it's a right triangle. If it doesn't work, then nope, it's either an obtuse or an acute triangle. Just like before, our very first step is to identify which 2 sides are our legs, our A and our B, and which side is our hypotenuse, our C. So our hypotenuse is across from our 90-degree angle, but it is also the longest side. So if we look at our 3 side lengths here, the longest side is going to be our hypotenuse. So our three different values, and I actually like to sketch a triangle, and I'm going to make it a right triangle, even though we're trying to figure out whether or not it actually will become one. So here's my slightly sloppy right triangle, and our side lengths are 9 6/10, 18, and 20 1/10. Well, our hypotenuse is the longest side. So which number is the longest? Which number is the biggest? 20.1. That would be our C, our hypotenuse. So 20 1/10. And then the other two sides make up our legs. Doesn't matter which one you pick A and which one is B. I usually just go in order. So side A will be 9 6/10. And side B will be 18. All right, we've labeled our information. So step 2, just like before, is going to be to substitute. We have our formula right here, A squared, 9 6/10 squared, plus B squared, 18 squared, equals C squared, 20 1/10 squared. Next step again is to simplify. So follow that order of operations. Do we have any grouping symbols? Nope, which means we can head straight into exponents. All right, these values are either all above 12 or they are not whole numbers, which means you do have permission to use a calculator. So 9 6/10 squared would be 9 6/10 times 9 6/10, 92 1600ths. And then 18 squared, 18 times 18 is 324. And then 20 1/10 squared is 404 1/10. All right, we're trying to see if these are really equal. Let's go ahead, keep simplifying. We're going to add our two legs together. So 92 1600ths plus 324 is, wrong color, 416 1600ths. Is that equal to our C squared, which was 404 1/10? No, those are not equal. They are not equal, which means these three sides do not form a right triangle. They may form a triangle, but not a right triangle. So our answer would be no, because it didn't make a true statement. The Pythagorean theorem didn't work. So nope, not a right triangle. Let's go ahead and do one more of these. So this one's very similar. It is like question 2 and 4 on your test. So we want to know if this set of side lengths form a right triangle. So once again, we can draw ourselves a picture if that helps you. And I'm going to go ahead and make it a right triangle, even though we're a little unsure. Let's label our three side lengths. Remember, the hypotenuse is the longest side. So out of 9, 12, and 15, 15 is the longest. That'll make it our hypotenuse. Therefore, 9 and 12 are our legs, so A and B. All right, step 2, let's substitute away. A squared, 9 squared, plus B squared, 12 squared, equals C squared, 15 squared. Exponents, do what you can in your head. Use a calculator for what you can't. 9 squared, 9 times 9 is 81. 12 squared, 12 times 12 is 144. And then 15 squared is one I don't have memorized. So 15 times 15 is 225. Next step is to simplify by adding our two legs together. 81 plus 144 is 225. Is that equal to our c squared, our hypotenuse squared? Yes, this one checks out, which means these three sides do in fact form a right triangle because it did work with the Pythagorean theorem, which means yes, this is in fact a right triangle. All right, this problem right here is similar to question 3 on your test. All right, use the polygon tool to draw a right triangle with hypotenuse GH. So I did make a little goof and I forgot to label this. So here's point G, here's point H. So all we need to do is make a right triangle, and we're told that this line segment we're given here is our hypotenuse. All right, let's choose a nice bright color. Let's do orange. Well, if I want to make a right triangle, I already got my hypotenuse, which means here and here. Does that make a right triangle? It does. Now, is there another way you could make a right triangle? Would there actually be a second correct answer? Hopefully you're thinking, Miss Zalestock, you can go below. Yeah, you could also make a right triangle by going this way. So either way, whether you make the triangle above or below the line segment, we got two right triangles here. So you're all set. That's my favorite question. I think it's the easiest. Okay, two vertices. Oh, before I start this, sorry, this is like question number 5. Two vertices. So vertices are your endpoints of a triangle. Have coordinates 3, -4, and 6, 1. Select each ordered pair that could be the coordinates of the third vertex. Well, if we think back to that problem we did, remember how when you have 2 points, you could make the triangle above or below? That's why this is a select all that apply, because we could create 2 different triangles. Now, there's different strategies that you guys can use to solve this, but me, I'm a very visual person. So when I solve problems like this, I either, 1, like to get a piece of graph paper and plot these points myself, or 2, use an online graph paper called Desmos to graph my 2 points, because I need that visualization. So here I just did this for you. Ooh, these grid lines didn't copy well, sorry. But here we have our 2 points, 3, -4, and 6, 1. So I like to connect the points in order to make my triangle. I need that visualization. So let's do my best here because this is a little fuzzy. So right there, that would make a triangle because 6, 1 and 3, -4 is our hypotenuse. So that third vertex that it's talking about is that third point in your triangle right here. This would be the third vertex. And that is at coordinate, that is at ordered pair 3, 1. So 3, 1, oh, looky there, that's one of our answer choices. So that's one possibility. But remember, whenever we have a line segment, whenever we have a hypotenuse, I can also make a triangle beneath it. So if we did our points this way, we would also have a right triangle. And then this vertice, so that little corner point, would be at 6, -4. Is that an answer choice? Yes, it is. All right, even though I'm feeling pretty confident about my answer, let's go ahead and look at the other two choices to make sure I didn't miss anything. So 6, -3 would be about right here, because like I said, I hope that this recording shows the graph better than my computer screen does. Oh, nope, that's not going to make a right triangle. That the two lines would be really tiny. That'd be a teeny tiny angle. Here we could even draw it in red to see how that would not work, because it would be like that. That's not a right triangle, is it? No, no, no. And then 1, -4, that would be like right here. Yeah, does that look like a right triangle? I know my writing's sloppy, but no, it's certainly not. So I didn't miss anything. Neither of those other two answer choices are correct. So we can move on. All right, now we're kind of moving into another part of using the Pythagorean theorem. So we've used the Pythagorean theorem to find missing side lengths, to determine whether the three sides make a right triangle, and then we've also created right triangles. Another way we can use it is to find the distance or to find the length. And that is what this is all about. And this question type is very similar to number 6 and number 7 on your test. All right. To the nearest hundredth, what is the length of line segment AB? And once again, I made a little goof, forgot to actually label them. So here is point A and point B. There's a couple different ways that you can do this, but you don't need to actually memorize a brand new formula. You can do like we just did and create a right triangle. And by creating a right triangle, we can then use the Pythagorean theorem to find the length, to find that distance. Let's go ahead and make ourselves a little right triangle here. So I'm just going to make it up above because that's where I have room. There's my triangle. And if it's a right triangle, that means this is our right angle. Therefore, which one of these sides is our C? Which one is our hypotenuse? Our blue one, our AB, the one we're being asked to find. Now, you might be thinking, Mrs. Ailstock, great, you drew a triangle, but you don't know what the other two sides are. Yes, you do. You have a graph. You have a nice grid that counts by ones. And because it's a straight line, it's not a diagonal, can you count the length? I bet you can. All right. Oh, let me get my spotlight again so you guys can see me counting. So we have 1, 2, 3, 4, 5. So this leg is 5 units tall. And then our second leg, 1, 2, 3, 4, 5, 6. It is 6 units long. Now we have a problem very similar to the first two, and we can use the Pythagorean theorem to find the length, to find the distance of line segment AB. So the Pythagorean theorem says a squared, which would be one of our legs, so 5 squared, plus b squared, our other leg, 6 squared, is equal to c squared, our hypotenuse, and that is our line segment. That's what we don't know, which means it stays a variable. 5 squared is 25. 6 squared is 36. And that's still equal to c squared. I don't know. What comes next? Do you remember the next step? Hopefully you said to add because we're continuing to simplify and we need to add 25 and 36. That is 61. All right, what's the next step? Yeah, we got to find C, so we need to do the inverse, the opposite of a square, which is a square root. Is 61 a perfect square? No, because 7 times 7 is 49, and then 8 times 8 is 64. That means we are going to have to use a calculator, and we're going to receive a decimal answer. But that's a-okay, because if we pop back up and look at our directions, it tells us to round to the nearest hundredth. So that means it was a possibility to get a non-perfect square. All right, square root of 61. So I'm going to write way more than the nearest hundredth on here so we can make sure we talk about rounding. So when we take the square root of 61, we have 7, and then 8, 1, 0, 2, and I'm going to stop writing at that point. I'm going to truncate it, so I'm going to stop it. And that is equal to C. Well, if we round to the nearest hundredth, that means 2 decimal places, because remember with decimals, we go tenths, hundredths, thousandths, etc. So we want to round to the nearest hundredth. That would be this second decimal point. In order to round to the second decimal point, we actually need to look at the third number. So we need to look in the thousandths place because that will tell us whether we round up and make it 7 and 82 hundredths, or whether we round down and it becomes 7 and 81 hundredths. With rounding, if the number that you're using to round, if it's a 5 or above, you round up. If it's a 4 or below, you round down. So that's 0, therefore we round down, and our value for C, the distance of AB, is 7 and 81 hundredths. That is our distance, that is our length. The Pythagorean theorem can be used in lots of ways. I love that because that means you only got to memorize one theorem, one formula. It works for a ton. All right, last but not least, guys, we're almost done. We now have a word problem, and this is very similar to questions 9 and 10 on your test. A soccer field is a rectangle 90 meters wide and 120 meters long. The coach asks players to run from one corner to the corner diagonally across the field. How far do the players run? My biggest suggestion when it comes to word problems is to draw a picture, because you're going to see that the work is not super different. However, for me personally, if I don't have a visual, if I don't have a picture, then I have a hard time knowing, are the 2 pieces of information given my legs, or did I get a leg and a hypotenuse? Which one of these am I trying to find? So we have a soccer field and it's a rectangle. All right, let's draw that. Let's make it green since soccer fields are grass. All right, so here's our beautiful soccer field. It's a rectangle and it's 90 meters wide and 120 meters long. And the coach asks for players to run from one corner to the other corner. And it doesn't really specify, and because it's a rectangle, do you think it matters? No, not really. Let's just go ahead and draw a diagonal this way. All right. Once we draw that diagonal, we have two different right triangles. We have a right triangle here and a right triangle here. If we have a right triangle, what does that mean we can use? Yeah, the Pythagorean theorem. But wait, I only labeled two of my sides and it doesn't look like it matches up. Oh, guess what? We can fix that problem because remember, with a rectangle, opposite sides are congruent. They are equal. Therefore, this is also 120 meters. This is 90 meters. So now we can visualize either triangle because they're both identical. Let's say we pick this bottom one here. We'll kind of highlight it in red. We got a triangle. Let's use the Pythagorean theorem. All right, the two pieces of information given, did they give us two legs or did they give us one leg and a hypotenuse? They gave us two legs because that diagonal, that corner to corner, is across from your 90-degree angle. So we are trying to find our C. If we substitute a squared, 90 squared, plus b squared, 120 squared, equals c squared. That's our unknown. All right, definitely need a calculator for this. I don't expect you guys to have that memorized. 90 times 90 is 8,100 plus 120 squared, 120 times 120, 14,400. Even though this one actually, some of you guys might have been able to figure it out without a calculator. And if you did, bravo, props. Equal to c squared. Let's keep simplifying and add those bad boys up. 8,100 plus 14,400 is 22,500. That is equal to c squared. What do we need to do? The inverse of a square is a square root. Take the square root of both sides. So I'm turning my calculator sideways. 22,500. The square root of that is 150. So that means the players ran, because it wanted to know how far the players run, they had to run 150 meters. And that, in fact, is it, guys. We have now covered example problems for every single question on your Unit 6 test, the Pythagorean Theorem. I hope this helped you study. I hope it helped you clarify. Remember, you have multiple attempts on that test. So please, if you have already taken it, go back, try it again. Make sure you have a pencil, a piece of paper, and a calculator handy, because as you could see, I had to show a lot of work, and I definitely don't want you to get some of those numbers mixed up and therefore type the answer in wrong or choose the wrong answer. So good luck, guys. I know you can do it. And as always, if you have any questions, just reach out to your math teacher and we'll be more than happy to help you. All right, bye.